Hi everyone, my name is Arlene Reyes and today I will present our research project titled Classifying Motions and Affordance Factors of Tangible Objects for Endometriosis Symptom Tracking, conducted at the Heart Lab at Carnegie Mellon University in collaboration with University of Guadalajara under the mentorship of Professor Heni Admoni and PhD student Suleika Karachiwala. Endometriosis is an incurable chronic condition causing severe pain, fatigue, mood disturbances, and many other symptoms. With no cure, symptom tracking is essential for symptom management. We propose a tangible user interface as a new form of symptom tracking for people with endo to log symptoms through physical interactions with a tangible device. Our main research question is: what affordance factors and motions on tangible objects express the somatic experience of endometriosis? For our study design, our participants were women diagnosed with endometriosis. Our workshop activities were body mapping, manipulate tangible objects, explain symptom experience, rank symptoms, group and discuss objects. And for data collected, we were body maps, audio and video recording, whiteboard notes, symptom ranking forms, object interaction, and artifacts. Our study followed a line starting with requirement, followed by workshop preparation, workshop session, data collection, and data analysis. My personal contribution to this project were participant requirement and study coordination. Managed participant requirement by identifying requirement channels and coordinating communication, scheduling, tracking, and compensation, and designing a requirement pamphlet. Study preparation assisted in developing, refining, and preparing workshop materials through pilot workshop evaluations. Workshop facilitation supported workshop facilitation, participant assistance, and documentation, including achieving forms and artifacts. For data processing, I transcribed participants' responses for the symptom ranking forms into a central database, recording symptom scenarios, selected objects, motion description, and satisfaction ratings. For data analysis, I systematically reviewed workshop video recordings, extracted image sequences, and time-lapse for every interaction to observe the exact motions. And finally, I verified and mapped each interaction against our predefined motion taxonomy and identified key affordance factors by combining participants' spoken reasoning with their physical actions. To ensure that our findings reflected truly effective expressions, we only analyzed interactions rather between 3 and 5 on a 5-point satisfaction scale. In this first chart, we clearly see that squeeze is the dominant motion with 14 recorded instances, followed by bend with 6 and rotate with 5. For fatigue, squeeze remains the most frequent motion, but stretch and lift emerge as key interactions, reflecting slower, sustained movement associated with heaviness and low physical energy. For mood disturbances, we observe a broader variety of motions, while squeeze is still predominant, stretch and shear stand out, highlighting the complexity and variability involved in expressing emotional experiences. Across all categories, squeeze emerged as the universally preferred motion, serves as a versatile physical metaphor for expressing symptom experience beyond pain alone. Looking at pain objects, participants predominantly select objects 36, 35, 8, 34, and 10, which share qualities like being soft, deformable with resistance, or featuring spikes textures. For fatigue, the chart highlights objects 32, 29, and 5, which were selected for their weight, soft deformable materials, or ease of being comfortably held in the hand. For mood disturbances, participants favored objects with featuring mobile parts, elastic materials, or resistance, supporting more dynamic interactions. These preferences demonstrate that object selection was driven not by object identify itself, but by the physical affordance the objects embodied. Here we see that the primary affordance factors for pain were deformability, mobile parts, and material, which allowed participants to squeeze, manipulate, or feel distinct surface textures. For fatigue, weight played a prominent role alongside deformability and mobile parts, helping participants communicate feelings of bodily heaviness, brain fog, or moving through a dense medium. Finally, mood disturbances were primarily linked to deformability, mobile parts, and material. Notably, there is a high count of unclassified responses, indicating that participants often use subjective or context-dependent language to express emotions. In summaries, low effort tracking, tangible interaction bypass cognitive load, and screen fatigue during severe flare-ups. Natural expression, physical emotion capture complex pain, fatigue, and mood disturbances. And clinical communication, motion summaries improve doctor-patient insight. Our future work includes TUI prototype, build functional tangible interface based on classifying motion patterns. AI generation, implement generate AI to recognize and summarize physical motions in real time. And real-world testing, evaluate the final system with endometriosis patients during actual flare-ups. I would like to thank my advisor, Dr. Henny Admoni, and my PhD student, Suleika, for their mentorship throughout this project, all the research team members for their great work and help, the Heart Lab, Carnegie Mellon University, the Reyes program, Rachel Bursin, and Dr. John Dolan for the opportunity, and all the participants who generously shared their experience with us. Thank you so much.